Good morning. As the sun begins to paint the Alaskan sky with hues of orange and pink, a sense of tranquility often settles over the vast landscape. The crisp morning air carries the scent of pine and the distant sound of the ocean. But on this particular morning, that peace was about to be shattered. Today, July 16, 2025, Alaska was rocked by a major earthquake. The ground trembled with a ferocity that sent shockwaves through communities and sparked immediate concern across the state and beyond. News outlets scrambled to report on the unfolding event, broadcasting images of rattled homes and anxious residents. The USGS reported a magnitude 7.4 quake, a significant seismic event capable of causing widespread damage and triggering secondary hazards. Seismographs around the world registered the Earth's movement, providing crucial data for scientists to analyze the quake's characteristics. Centered 55 miles southwest of Sandpoint, Alaska, in the Aleutian Islands, the earthquake's location raised immediate concerns due to its proximity to coastal communities and the potential for generating a tsunami. The Aleutian Islands, a chain of volcanic islands stretching across the Bering Sea, are known for their seismic activity. The quake struck at 12:48 a.m. Alaska Daylight Time, a time when most residents were sound asleep, unaware of the impending danger. The darkness of the Alaskan night amplified the sense of vulnerability as the earth began to shake. Waking residents in coastal communities like Sandpoint, the sudden jolt threw people from their beds and sent them scrambling for safety. The initial moments were filled with confusion and fear as families struggled to understand what was happening. Cold Bay and Kodiak, these towns, nestled along the Alaskan coastline, are accustomed to the rhythms of the sea. But the earthquake introduced a new and terrifying element of uncertainty. At a depth of about 20 miles, the earthquake's epicenter was relatively shallow. This shallow earthquake was felt intensely on the surface. The proximity to the surface amplified the shaking, causing buildings to sway, objects to fall, and the ground to undulate in a disorienting manner. Shallow quakes like this can displace the ocean floor, creating a sudden vertical movement that can generate powerful tsunami waves. The potential for a large-scale displacement was a major concern for authorities, raising immediate tsunami concerns. The possibility of a wall of water crashing onto the coastline prompted swift action from emergency management agencies. The region sits on the Ring of Fire, a horseshoe-shaped belt around the Pacific Ocean known for its intense volcanic and seismic activity. This geological setting makes Alaska particularly vulnerable to earthquakes and tsunamis. So Alaskans are no strangers to seismic activity, having experienced numerous earthquakes throughout their history. This has led to a culture of preparedness, with many residents knowing what to do in the event of a quake. But a quake of this strength always demands attention. Even in a region accustomed to seismic events, a magnitude 7.4 earthquake is a serious threat that requires immediate assessment and response. The focus quickly shifted from the shaking to the threat of a tsunami. While the earthquake itself caused damage and disruption, the potential for a tsunami loomed even larger, threatening to inundate coastal communities. The National Tsunami Warning Center in Palmer, Alaska, sprang into action, its team of experts working diligently to analyze the data and determine the level of tsunami risk. The center serves as a critical hub for monitoring seismic activity and issuing timely warnings to protect coastal populations. Analyzing the event for tsunami potential. Scientists meticulously examined the earthquake's characteristics, including its magnitude, depth, and location, to assess the likelihood of a tsunami forming. Given the quake's magnitude, depth, and location, all key factors in determining tsunami potential, the warning center had to act fast. The risk of a tsunami was real. The combination of a shallow earthquake in a seismically active region created a dangerous scenario that demanded immediate attention. Initial data prompted an urgent response. The warning center issued a tsunami advisory for coastal areas near the epicenter, urging residents to be prepared to evacuate if necessary. The first moments after a major undersea quake are critical, as the window for issuing effective warnings and initiating evacuations is limited. Every second counts in saving lives and minimizing damage. As scientists race to assess the danger and issue alerts, emergency management agencies work to coordinate evacuation efforts and ensure the safety of coastal residents. The rapid dissemination of information is crucial in these situations. For Alaska's coastal residents, who live with the constant awareness of the potential for earthquakes and tsunamis, this was a moment of truth. their preparedness and the effectiveness of the warning systems would be put to the test. Every second counted. The race against time had begun, with the lives and livelihoods of countless Alaskans hanging in the balance. Immediately after the earthquake, seismic sensors detected the magnitude and location of the event. These initial readings are critical, serving as the trigger for a series of automated assessments and alerts. The speed of this initial response is paramount in mitigating potential damage from a tsunami. The National Tsunami Warning Center issued a tsunami warning. This warning wasn't issued lightly. It followed a strict protocol designed to protect coastal communities. The center's team of experts immediately began analyzing the earthquake data, factoring in historical data and geological information to assess the likelihood of a tsunami. A tsunami warning means dangerous coastal flooding and strong currents are possible. It's not just about large waves. The surge of water can inundate low-lying areas, and even a relatively small tsunami can generate powerful currents capable of sweeping people and objects out to sea. Move to higher ground now. Time is of the essence, and every minute counts. Evacuation routes are clearly marked in coastal communities, guiding residents and visitors to safe zones located at higher elevations or inland. The warning covered the Alaskan coast from Kennedy Entrance to Unimak Pass. This extensive area highlights the potential reach of a tsunami generated by a significant earthquake in the region. Coastal communities within this zone were immediately notified and advised to take precautionary measures. Scientists monitored deep ocean dart buoys for real-time sea level changes. These buoys are strategically positioned throughout the ocean to detect subtle changes in water pressure, which can indicate the passage of a tsunami wave. To confirm if a tsunami was generated, the data from these buoys provides critical validation, helping scientists differentiate between normal ocean activity and the distinct signature of a tsunami. This data is crucial for refining predictions and updating alerts. The more accurate the data, the better the ability to predict the tsunami's arrival time and potential impact on different coastal areas. About an hour later, the warning was downgraded to a tsunami advisory. This downgrade reflected the analysis of the dart buoy data and other real-time observations, indicating that the threat of a major tsunami had diminished. An advisory means strong currents and waves are still possible. Danger remains for those near the water. Even though the threat of widespread inundation had decreased, the ocean remained unpredictable, and caution was still advised, especially for those engaged in activities near the shoreline. The system worked as intended: initial caution, then adjustment as real data came in. This adaptive approach ensures that communities are adequately protected without causing unnecessary disruption. This approach avoids unnecessary evacuations while keeping people safe. Overwarning can lead to complacency, making people less likely to respond appropriately to future threats. Staying alert and following updated guidance is essential during these events. Understanding the difference between a warning and an advisory, and knowing how to respond to each, can save lives. Coastal communities like Kodiak, Sandpoint, and Cold Bay were put on high alert. Sirens sounded, and emergency crews moved residents to higher ground such as local schools. Estimated wave arrival times were provided. Sandpoint at 1:45, Cold Bay at 2:10, Kodiak at 2:45 a.m. Even after the alert was downgraded, vigilance remained high. Focus shifted to securing harbors and warning people to stay away from the water. Harbor masters ensured boats were secured and docks cleared. Tsunami drills and clear evacuation routes paid off as residents responded calmly and efficiently. Trust in the system and preparedness made a difference. This event reinforced the importance of readiness and community response. So what exactly is a tsunami? It's a question that often comes to mind when we see the devastating impact these natural disasters can have. Unlike regular waves, the ones we see every day, gently lapping at the shore, which are caused by wind disturbing the water's surface, tsunamis have a far different origin and behavior. A tsunami isn't just a single monstrous wave, but rather a series of waves, often referred to as a wave train. These waves can arrive minutes or even hours apart. This powerful phenomenon is triggered by a massive disturbance beneath the ocean's surface, a sudden jolt that displaces an enormous volume of water. Most commonly, this disturbance is an undersea earthquake, where the Earth's tectonic plates abruptly shift and collide. Volcanic eruptions and landslides can also cause tsunamis, though less frequently. What sets a tsunami apart is that the entire water column, from the surface to the seabed, is set in motion, not just the surface layer as with wind-driven waves. This is what gives tsunamis their immense power. In the deep ocean, a tsunami wave is often barely noticeable. It might pass under a ship without anyone on board even realizing it, because the wave height is so small relative to the ocean's depth. But as these waves approach land and enter shallower waters, they undergo a dramatic transformation, growing rapidly in height. This is where the danger truly begins to manifest. This phenomenon, known as shoaling, compresses the wave's immense energy into a smaller volume, forcing the water upwards. This process turns what was once a small, almost imperceptible offshore ripple into a towering surge of water as it reaches the coast, capable of causing widespread devastation. Unlike a typical breaking wave that crashes and recedes, a tsunami acts more like a fast-moving flood, inundating the land with a relentless surge of water. This surge moves inland with immense force, capable of sweeping away buildings, vehicles, and anything else in its path. The danger posed by a tsunami comes not only from the sheer height of the water, which can reach tens of meters, but also from its unstoppable momentum, the sheer volume of water moving at high speed. Adding to the destructive power is the debris carried by the waves, trees, cars, and building materials, which act as battering rams, further amplifying the devastation. It's crucial to understand that tsunamis are a series of surges, not just a single wave event. The first wave may not be the largest, and the danger can persist for hours. Therefore, understanding tsunamis as a series of surges, and not just one wave, is key to appreciating their danger and responding appropriately to warnings. Why do earthquakes cause tsunamis? The Alaska quake happened at a subduction zone where the Pacific plate dives beneath the North American plate. When stress builds and the plates suddenly slip, the seafloor can thrust upward, displacing massive amounts of water. This vertical movement launches tsunami waves in all directions. Magnitude, depth, and fault movement direction all matter. Vertical shifts are most dangerous. Scientists quickly analyze seismic data to forecast tsunami risk. In this case, the quake had the right ingredients, but real-time buoy data showed the actual tsunami was smaller than feared. The alert was downgraded as a result. A crucial safety tip. The first tsunami wave is rarely the largest. People may see a small wave and think it's safe, but later waves can be much more dangerous. Tsunamis arrive as a series of waves, sometimes hours apart. The shape of the coastline and seafloor can amplify later waves. That's why alerts remain in effect long after the first wave. Water levels can fluctuate unpredictably, with receding water followed by sudden surges. Only return to coastal areas when officials give the all-clear. Don't trust your eyes. Trust the science and the warnings. Patience is vital. It can save lives. Wait for the official all-clear before returning. Even without massive flooding, tsunamis create dangerous currents. These currents, especially in harbors and river mouths, can be far stronger than normal tides. Boats can break free, crash into docks, and cause major damage. The currents can also carry debris, creating additional hazards. For anyone near the water, these currents are life-threatening. That's why tsunami advisories are serious. Stay out of the water and away from the shore. The ocean's behavior is unpredictable during an advisory. Respect the warnings, even if the waves seem small. The good news: no major flooding was reported in Alaska. The downgrade to an advisory spared communities from catastrophic inundation. Still, the danger from strong currents remained. Emergency services focused on keeping people away from beaches and harbors. This event highlighted the importance of understanding different alert levels: warning, advisory, and watch. Each requires a different response. Know what to do for each. The system's goal is always safety, and it worked as intended. Even small tsunamis can be hazardous if warnings are ignored. Respect for the ocean and the alert system is essential. The most important lesson: stay informed and follow official guidance. Reliable updates come from the National Tsunami Warning Center and local emergency offices. Have multiple ways to receive alerts: NOAA weather radio, wireless emergency alerts, and local news. Don't rely solely on social media. Verify with official sources. Know if you live in a tsunami hazard zone and your evacuation route. Prepare a go bag with essentials. Preparation means you can act quickly when an alert is issued. This Alaska event is a reminder that natural disasters can happen anytime. Science and technology give us early warnings, but preparation saves lives. Review your emergency plan now. Know your zone, have a kit, and stay informed. That's the best way to be ready for the next alert.